Hello everyone. Today in this video we will discuss about the particular integral, and in my last lecture we have discussed the complementary function. Complementary function exists only complementary function exists for homogeneous differential equation, okay, and particular solution exists for non-homogeneous differential equation. Non-homogeneous means the right hand side will be some non-zero function, okay. So let's start today's topic, particular integral. Suppose we have a differential equation d2y dx2 plus p1 dy dx plus p2y, this is equals to, let's say, capital X. Okay, actually this differential equation we can write in this form, that d2 plus p1d plus p2 into y equals to capital X. So this d2 plus p1d plus p2, this is nothing but this is function of d. Yes or no? This is function of d. So function of d y equals to capital X. This is the general form of any second order ordinary differential equation. So f of d y equals to capital X. We already have learned about the complementary function, how to find out complementary function. And today's topic is how to find out particular integral. So depending on the nature of capital X may be exponential function, capital X may be polynomial, may be any trigonometric function. Okay, so depending on the nature of capital X, there are total 7 types of particular integral. Okay, so let's discuss one by one. So first one is case 1. In case 1, let's take the easiest one. Okay, when capital X, this is equals to the exponential function e to the power ax. Okay, that means the given differential equation, this is of the form f of d y, this is equals to e to the power x. The right hand side is e to the power ax. Okay, so in this case, actually you can find out the complementary function. Complementary function, this is nothing but just first you have to write f of d y, this is equals to 0. When you are calculating complementary function, you have to take the right hand side 0. Then you can calculate yc equals to something. Okay, but this is not our concern. Our concern is just we have to find out the particular integral. The process is p dot I, particular integral, this is equals to 1 by f of t into capital X. Okay, 1 by f of t to capital X. Now in this problem, what is our capital X? E to the power ax. So 1 by f of t e to the power x. Remember, when the right hand side of the equation is e to the power ax, this is easiest problem. Okay, just you have to write e to the power ax divided by, here f of d. F of d is nothing but function of capital D. Just you have to replace capital D by this number a. That means e to the power ax divided by f of a. Clear? Suppose the equation is d2 plus 2d plus 1. Okay, into y, this is equals to e to the power x. I am taking an arbitrary example. Okay, so you can calculate the yc. Just let's take the pi. Okay, in this case pi will be pi equals to 1 by d2 plus 2d plus 1. This is our f of t e to the power x. What is the value of a? 1. So the answer will be e to the power ax divided by 1 square plus 2 into 1 plus 1. That means e to the power this is x. E to the power x, and this will be e to the power x divided by, this is 4. Okay, this is our particular integral, e to the power x by 4. Okay, this is the process. So let's understand using an example. First question. solve d2 minus 3d plus 2 into y, this is equals to e to the power 2x. Since this is non-homogeneous equation and every non-homogeneous equation contains both complementary function and particular integral. So first you have to calculate the complementary function solution. So process is same. Let y equals to e to the power mx be a trial solution. Okay, then the auxiliary equation is m square minus 3m plus 2 equals to 0. Okay, m square minus 3m plus 2 equals to 0. Just solve this equation. So or m square minus 2m minus m plus 2 equals to 0, or m is common, so this will be m minus 2 minus m minus 2 equals to 0. So you are getting m minus 1 into m minus 2 equals to 0. This implies m equals to 1 comma 2. And you know, when the roots are distinct real roots, so what will be the complementary function? Yc is equals to c1 e to the power m1x. Here m1 equals to 1, so c1 e to the power x plus c2 e to the power 2x. This is your complementary function. Now you have to find out the particular integral. So pi, this is equals to, formula is 1 by f of d, that means 1 by d2 minus 3d plus 2, okay, into e to the power 2x. So this is equals to e to the power 2x divided by, so this will be 2 into 2 4 minus 6 plus 2. Okay, now here you can see that the denominator is 0. Yes or no? The denominator is 0, but we know that we cannot divide by 0. That means this result is undefined. Now how to solve this question? So again, let's come to the theory part. Here e to the power ax by f of a. So obviously this result will be defined when f of a, this is not equals to 0. Now question is, if f of a equals to 0, simple. If f of a equals to 0, in that case 1 by f of d e to the power ax, that will be equals to, just if f of a equals to 0, just you have to multiply by x. So x into e to the power ax divided by single derivative of f of a, that means f dash a. Clear? So obviously in this case f dash a, this is not equals to 0. If f dash a equals to 0, then again that will be undefined. Okay, now again I am asking that if f of a equals to 0, f dash a equals to 0, both are 0, then, so next case, if f dash a equals to 0, okay, f of a equals to 0, also f dash a equals to 0, then 1 by f of d e to the power ax, this is equals to, here you have to multiply again x and again you have to derive, so that will be x square e to the power ax divided by f double dash a. Yeah, this is the process. So similarly, if f double dash a is not equals to 0, so again if f double dash a equals to 0, then again you have to multiply x, again you have to derive f double dash a. Okay, this is the process. So let's come to the problem. So here you can see that the denominator is 0. That means here we have to multiply x and we have to derive the denominator. Okay, so that will be x e to the power 2x divided by, what is the derivative of fd? So that will be 2d minus 3. Yes or no? And you have to write d equals to m. So that will be 2 into, what is the value of a? 2. So 2 into 2 minus 3. So this is equals to x e to the power 2x divided by 4 minus 3, that means 1. So pi is equals to x e to the power 2x. Now, what is the general solution? So final answer is, so the general solution is, general solution is y is equals to yc plus yp. Okay, so this is equals to, what is yc? c1 e to the power x plus c2 e to the power 2x. Okay, plus what is yp? X e to the power 2x. This is your final solution, where c1 c2 are arbitrary constants. Okay, this is the final solution. In this way, you have to solve this type of problem. First, calculate the complementary function, then use the formula of particular integral, then just addition of complementary function and particular integral, you will get the general solution. Clear? So this is the case 1 problem. Case 1 means, in this case, the right hand side is exponential function e to the power ax. Now come to the next case, case number 2. Case 2. Case 2 is, if the right hand side, this is polynomial. Okay, first case was e to the power ax. Now second case is, if the right hand side is polynomial. That means if capital X, this is equals to polynomial of x. Okay, so what will happen? In this case, pi is equals to 1 by f of d, here polynomial px into px. So this is equals to f of d inverse p of x. Just you have to inverse this result. Okay, f of d inverse. Just you have to inverse this f of d. Okay, let's understand using an example. Okay, and this process is very, very important. Definitely you will get at least one question from case number 2. Okay, so let's understand using an example. Solve d2 plus 4d plus 3 into y equals to x square plus 3. Solution. Obviously non-homogeneous equation. So first we have to calculate yc, then yp. So let y equals to e to the power mx be a trial solution. Okay, then the auxiliary equation is m square plus 4m plus 3 equals to 0. Now just simple solve this equation. Or m square plus 3m plus m plus 3 equals to 0. Or m into m plus 3 plus m plus 3, this is equals to 0. So you are getting m plus 3 into m plus 1. That means you have two roots, m equals to -1 and -3. Okay, so obviously two different roots and real roots. So the complementary function will be yc equals to c1 e to the power minus x plus c2 e to the power minus 3x, where c1 c2 are arbitrary constants. Now let's understand how to find out yp. So yp equals to 1 by f of t, that means d2 plus 4d plus 3, okay, into x square plus 3. Now process is you have to inverse this f of t, fd inverse, but there is some trick. First you have to take common this 3, okay, so this is equals to 1 by 3. First you have to take common the constant number, okay, 1 by 3. So this will be 1 by 1 plus d2 plus 4t divided by 3, yes or no? 1 plus d2 plus 4t divided by 3, clear now? And this is x square plus 3, okay. Now we can write this is equals to 1 by 3, 1 plus d2 plus 4t by 3 whole inverse. Yes, in this way you have to inverse f of t. First you have to take common the constant number, then you have to write in the form of 1 plus x inverse, okay. We know that you have a formula that 1 plus x inverse, this is equals to 1 minus x plus x square minus x cube plus dot dot dot. You have this formula, okay. So here this one, this is of the form 1 plus x inverse, yes. So let's use this formula, 1 plus x inverse is equals to this. So you are getting, okay, this is x square plus 3. So 1 by 3 into, what is x? X means d2 plus 4t divided by 3. So this will be 1 minus d2 plus 4t divided by 3. Okay, 1 minus x plus x square. X square means d2 plus 4d divided by 3 whole square. Okay, minus x cube. X cube means d2 plus 4d divided by 3 whole cube plus dot dot dot. Actually this is infinite series, okay, and you have to write x square plus 3. Now here x square plus 3, this is quadratic na, 2-degree equation or 2-degree polynomial, x square plus 3. So if the polynomial is 2-degree, so maximum we can derive this polynomial 2 times, because the 3 times derivative will be 0. So we can derive maximum 2 times. Okay, so that means we have to take from this expression, we have to take only single 1 terms, d terms and d2 terms. Because when you will take d3 means 3 times derivative, then the result will be 0. Clear? That means we have to take only these 3 derivatives: single no derivative, single derivative and double derivative. Okay, no derivative, single derivative and double derivative. So let's calculate the next part. Okay, this is equals to 1 by 3. First simplify this. 1 minus, this will be d2 by 3 minus 4d by 3, okay, plus, this is a plus b whole square, so that numerator will be d to the power 4 plus 8d cube plus 4d square, that means 16d square divided by 9. Okay, now here in this case, here you have d cube na, that means all the terms will be either 3 derivable or more than 3 derivable. That's why we are neglecting this term, because here you will get the result 0. Okay, so this is our final expression: 1 minus d2 by 3 minus 4t by 3 plus d to the power 4 plus 8d cube plus 16d square divided by 9. Here you can see that 8d cube divided by 9. So obviously this result from 8d cube divided by 9, you will get the 0 result. So we are getting finally 1 by 3, 1 minus. This is minus d2 by 3, and here 16 d square by 3. 16 d square by 9. Okay, so let's simplify this part. First 1. So from 1, you will get 1 into x square plus 3. That means x square plus 3 minus 1 by 3 into d2 x square plus 3. d2 means double derivative. So first derivative of x square plus 3 is 2x, and the second derivative will be 2. So 1 by 3 into 2. Clear? Minus 4d by 3 into x square plus 3. So 4 by 3 into what is derivative of x square plus 3? So that will be 2x plus 3. Okay, now next part. Here d to the power 4, that means d to the power 4 x square plus 3, that will be 0. d cube x square plus 3, that will be 0. So only you have 16 by 9 d square. So plus 16 by 9 d2 x square plus 3. d2 means that will be first derivative d of x square plus 3 is 2x. d2 x square plus 3, that will be 2. So 2. Okay, this is the final. So you are getting x square plus 3 minus 2 by 3, plus from here you are getting 8x by 3 minus 4, and from here this is 32 by 9. Okay, now just simplify this part. So yp is equals to, you are getting 1 by 3 into x square plus 3 minus 2 by 3 minus 8x by 3 plus 32 by 9. Okay, this is the simplest form. Now just simplify. So 1 by 3 x square minus 8x by 3 plus, now 32 by 9 minus 2 by 3 plus 3. Just you have to simplify this part. So you will get 53 by 9. So plus 53 by 9. Okay, so this is your particular integral. So the general solution is, so the general solution is y is equals to yc plus yp. So this is equals to, what is yc? c1 e to the power minus x plus c2 e to the power minus 3x plus 1 by 3 x square minus 8x by 3 plus 53 by 9. This is the final answer. Okay, remember, if this polynomial part, if this is cubic equation, you have to take up to d3. If this is degree with 4, you have to take up to d4. Clear? Because when you will take d5, the result will be 0. Okay, so in this way you have to solve this type of problem when the capital X is in polynomial form. Clear? Next question. Next topic is, if the capital X, this is, that means this is case 3. Case 3. When the capital X, this is any trigonometric function. Okay, let's say capital X, this is equals to sine ax plus b or cos ax plus b. The function is sine or cos, the rule is same. Okay, so if capital X is equals to sine ax plus b or cos ax plus b, in that case pi will be p dot I, this is equals to 1 by f of t. I am taking sine ax plus b, okay, because the rule is same for cos. So sine ax plus b, this is equals to. Process is just you have to write d2 is equals to minus a square, because this is second order differential equation, so obviously you will have d2. So in place of d2 you have to write minus a square, and the term capital D, that will be as it is. Okay, so 1 by, you have to write let me write phi of minus a square. Phi of minus a square means in this phi of minus a square, all the terms d2 are changed by minus a square, and the term d is as it is. So 1 by phi of minus a square sine ax plus b. This is the process. Okay, let's understand using an example. Similarly for cos, if this is cos, then similarly 1 by phi of minus a square cos of ax plus b. Solve d2 plus 1 into y, this is equals to sine 2x. Solution. First calculate the complementary function. Let y equals to e to the power mx be a trial solution. Then the auxiliary equation is m square plus 1, this is equals to 0. That means m equals to plus minus I. Okay, so obviously complex root, and you know when the result is complex root, the answer will be c1 yc is equals to e to the power, actually here the real part is 0, so that means e to the power 0 into x, and e to the power 0 is equals to 1. That's why I am neglecting. So only you will have c1 cos of x plus c2 sine of x. Clear now? c1 cos of x plus c2 sine of x. This is the complementary function. Now you have to find out particular integral. So yp is equals to 1 by d2 plus 1 sine 2x. Okay, the process is just you have to write minus a square in place of capital D2. Okay, this is not minus a whole square, this is only minus a square. Okay, you must write the negative sign. So this is equals to 1 by, what is the value of a? This is 2, so you have to write minus 2 square plus 1 sine of 2x. So this is equals to 1 by, this is minus 4 plus 1, that means minus 3 sine 2x. This is your yp. So what is the general solution? Y is equals to c1 cos of x plus c2 sine x minus 1 by 3 sine 2x. Clear? So in this way, we can solve the trigonometric problem. So at the right hand side is in trigonometric form. Okay, let's solve another problem of case 3. This is quite different. Solve d2 plus 9 y, this is equals to cos of cx minus 1. So first calculate the complementary solution. So let y equals to e to the power mx be a trial solution. Okay, then the auxiliary equation is m square plus 9, this is equals to 0. This implies m equals to plus minus 3i. Okay, so yc is equals to c1 cos of 3x plus c2 sine of 3x. Here the real part is 0, so e to the power alpha x, that will be 0. That will be 1. So yc is equals to c1 cos 3x plus c2 sine 3x. Now yp is equals to 1 by d2 plus 9 cos of 3x minus 1. This is equals to, now the rule is you have to write minus a square in place of d2. So in place of d2, if you write minus a square, so you are getting minus 9 plus 9. That means 0, na? And again 1 by 0 is undefined. Yes or no? 1 by 0 is undefined. The process is same. I already have told you in when we are learning the e to the power ax form. Here you can see this is the process. Sorry. Here, if the denominator is 0, then just you have to multiply x and you have to derive one time the denominator. Same process. Okay. So here you can see that the denominator is 0. So multiply by x into 1 by derivative of d2 plus 9. This is 2d into cos of 3x minus 9. I have told you when the capital X is sine or cos, then you have to write in place of capital D, you have to write minus a square. But here you can see you have 2d. There is no term of d2. Okay, so process is you have to convert this 2d into d square term. That's why I am multiplying capital D in both numerator and denominator. Okay, so x into capital D divided by 2d2 cos of 3x minus 1. Is it clear? I am repeating. Here you can see you have the term 2d, but I have told you you can write minus a square in place of d2, and the term capital D, that will be as it is. Okay, so now process is you have to multiply capital D in both numerator and denominator. Then the term 2d, that will be converted to 2d square. Then you can use the term d2 equals to minus a square. Yes or no? That's why I have multiplied capital D in both numerator and denominator. Okay, so this is equals to x by 2 into d of d2 means minus 3 square, that means minus 9 cos of 3x minus 1. Okay, so you are getting minus x by 18 d of cos 3x minus 1. D means derivative, so this is equals to minus x by 18, and d of cos 3x minus 1 is minus, derivative of cos is minus 3 sine 3x minus 1. Okay, so minus minus plus 3 into 6 18, so this will be x by 6 sine 3x minus 1. Is it clear? This is your particular integral. Okay, so what is the final solution? Final solution is y is equals to yc plus yp. And what is yp? c1 cos of 3x plus c2 sine of 3x plus x by 6 sine 3x minus 1. Okay, this is the final solution of this differential equation. Okay, in this way you can solve this type of problems where the functions are in polynomial form or in trigonometric form or in exponential form. In my next lecture we will discuss some problems where the capital X that are given in some product form, product of exponential and polynomial, or product of exponential and trigonometric, and so on. Okay, here today we have discussed when capital X is in single form. Single form means maybe capital X is exponential form, maybe this is polynomial or trigonometric, and in next lecture we will learn in product form. Okay, so thank you so much. If you have any doubt, so please feel free to ask me, and you can give me your feedbacks in my comment section. Thank you so much.